What if I told you that for every black hole, there could be a white one? Not a hole that swallows everything, but one that spews everything out. An object so violent, so impossible, that if it existed, it would be the most destructive force in the universe. Black holes we've seen, we've photographed them, we've heard them collide, but white holes? They're pure theory, pure math, pure... maybe. And here's where it gets strange. To understand white holes, you have to understand wormholes. And to understand wormholes, you have to understand something called negative energy, exotic matter, the Einstein-Rosen bridge. This is the physics of the impossible, or is it? Before we flip reality inside out, we need to understand what a black hole actually is. A black hole forms when a massive star runs out of fuel and collapses under its own gravity. The core crushes down to a point, infinitely small, infinitely dense. A singularity. Around that singularity is the event horizon, the point of no return. Cross it and not even light can escape. You're gone forever. Black holes are cosmic vacuum cleaners. They eat stars. They merge. They grow. We've detected their gravitational waves. We've imaged their shadows. They're real. But here's the question that keeps physicists up at night. Where does it all go? Einstein's equations say the singularity is a dead end. But what if it's not an end? What if it's a beginning? In 1935, Albert Einstein and Nathan Rosen published a paper. They were trying to unify gravity and electromagnetism. But in the math, they found something strange. A bridge, a tunnel through space-time connecting two distant points, two singularities linked by a tube. They called it the Einstein-Rosen bridge. Today, we call it a wormhole. But here's the catch. In their original math, the bridge was unstable. It would pinch shut instantly. Nothing could cross it, not even light. Decades later, other physicists looked at the equations again, and they found something Einstein missed. If a black hole is a one-way door into a singularity, what if the singularity has another side? What if matter doesn't just vanish? What if it emerges somewhere else? That emergence point is a white hole. A white hole is the mathematical opposite of a black hole. If a black hole has an event horizon where nothing can escape, a white hole has an event horizon where nothing can enter. Light can leave, matter can leave, but try to go in and you'd be pushed back, repelled, exiled. White holes don't swallow, they vomit. They spew out matter and energy in an endless, violent fountain. If a black hole is a cosmic drain, a white hole is a cosmic geyser. Here's the problem. We've never seen one, not even a hint. If white holes existed, they'd be screaming across the universe, flooding space with radiation and matter. We'd know. So why do physicists still take them seriously? Because the math won't let go. In general relativity, black holes and white holes are two sides of the same solution. If black holes exist, white holes should too. Unless something is preventing them, something like time itself. Here's where it gets really strange. Einstein and Rosen's bridge doesn't just connect two points in space. In theory, it connects a black hole to a white hole. Matter falls into the black hole, travels through the wormhole, and erupts from the white hole, on the other side of the universe, or another universe entirely. This is the wormhole dream. Interstellar travel, time travel, gateways to other dimensions. But there's a problem, a big one. The bridge collapses instantly, nothing gets through. Unless you have something to hold it open, something with negative energy, something exotic. Negative energy, it sounds like science fiction, but it's real. In quantum physics, empty space isn't really empty. Particles pop in and out of existence, virtual particles. And between two closely spaced plates, something strange happens. There are fewer virtual particles inside than outside. That creates a force, a negative energy density. This is the Casimir effect. It's been measured, it's real, and it proves that negative energy exists. Now imagine scaling that up. A lot. If you could create enough negative energy, you could theoretically hold a wormhole open, bend space-time in ways that shouldn't be possible. The stuff that does this? Physicists call it exotic matter, not antimatter, not dark matter, something else. Matter with negative mass. If you pushed it, it would pull toward you. If you dropped it, it would fall up. We've never found exotic matter, but we haven't proven it can't exist either. And if it does exist, wormholes become possible, white holes become possible. Everything changes. So where does this leave us? Are white holes real? Some physicists think they might explain the Big Bang. What if our entire universe erupted from a white hole? What if the singularity we call the Big Bang was actually the other end of a black hole in another universe? It's called the Schwarzschild cosmology, and it's not crazy, it's just unproven. Others think white holes could explain gamma-ray bursts, those brief blinding flashes of energy from deep space. Maybe they're white holes, finally letting go after billions of years. But most physicists think white holes can't exist in our universe. Not because the math forbids them, but because of time. Black holes have a direction, forward, in time. White holes would be the reverse. They'd violate the second law of thermodynamics. They'd spit out ordered matter from chaos. They'd be backwards. And in our universe, time only flows one way. White holes may not exist. Wormholes may be forever closed. Exotic matter may be a fantasy. But here's the thing about physics. Every time we think we understand the rules, the universe breaks them. 100 years ago, black holes were pure math, science fiction. Today, we've photographed one. White holes are where black holes were a century ago, waiting, maybe. And even if they never exist, thinking about them teaches us something profound about time, about reality, about how little we actually know. The universe is stranger than we can imagine, and the only thing we know for sure is that we don't know much at all. Black holes, white holes, wormholes, exotic matter, the Einstein-Rosen bridge. They're ideas, theories, dreams, but they're also questions, and questions are where science begins. So keep looking up, keep asking, because the next great discovery might be hiding in a piece of math someone thought was impossible. This is Cosmic Pulse. And remember, the universe doesn't owe us answers, but it never stops us from asking.